Hello, today we're going to practice for Study Island 5th grade math equivalent fractions and decimals. We're going to practice with a little bit of IXL and just equivalent decimals first. So let's take a look at this question. Are 2/10, or that could be read as 20 hundredths, and 0 equivalent decimals? Well, the first thing I need to do is go take a look at this right here. Before the decimal, zeros, nothing changes, they're the same. And then I have 2/10, and here I have 0/10. So I should be able to look at this and know pretty quickly, no, these are not equivalent, because 2/10 is the same as 2 dimes, if you want to look at it that way, and this is the same as having 0. So we look at the next one, and the next one says, which decimal is equivalent to 51 8/10? Well, when comparing them, let's start with left of the decimal first. There's 51 the same. 50 is different, so we know that's not it. 52 is too big, that's not it. And this is 51, so we really only have one choice here, and that's the 51 8/100. Now, when comparing decimals, you can always look at it like this. When you add zeros to the right of the decimal, you're not really changing the value, okay? It's the same. So if I really wanted to compare these two, I could add a couple of zeros here and say, look, it doesn't change at all. Those become exactly the same numbers. Therefore, this one is equivalent. So we look here at 4 86 hundredths as compared to 4. So if I write that down, 4 86, and then compare it to the 4 here, which is a 0. Well, I have 2 digits to the right of the decimal, so let's put 2 digits to the right of the decimal there. I can tell that these are not equivalent. To the left of the decimal, they're the same, but once we get to the right of the decimal, this has 8/10, this has 0/10. So these are not equivalent decimals. Now we look here. This gets a little bit confusing. They're trying to be tricky with this. So we have 0 and 330 thousandths, and we have 0 and 3030. Now, if I want to compare, I can add the 0 there so they have the same number of digits, but I really only have to go as far as the hundredths place, because the tenths place is the same. The hundredths place, the 3 is greater than the 0, therefore these are not equivalent fractions, or decimals, excuse me, they're not equivalent decimals. And we can look here, again, let's take a look. 50 and 68 hundredths, 50 and, there's the 68, and with 2 zeros behind it. Now they are exactly the same before the decimal, they're exactly the same 2 digits after. If I want to fill it in to compare it evenly, I add the zeros. Those are exactly the same. So are they equivalent? Yes, because equivalent means equal, and these are equal in the long run. Let's do another one. Let's see here. Can we take a look here at this 1 and, here we have 8/10. Okay. Here we have, or that can be read even further, we have 1 and 80 hundredths, 1 and 40 hundredths, 1 and 7 ten thousandths, because this would be 10 hundred thousandths, 10 thousandths, and this is 1. I can tell by comparing just the ones in the front, oh, they're all going to have 1 to the left of the decimal. Then I go to the right, which has the 8. Here's the 8, that could be it. Nope, too low, definitely not. So here, these are actually equivalent. I could, again, add a couple more zeros behind there just to compare apples to apples. So that's how you're deciding if decimals are equivalent. You need to compare the same number of digits or just find the first digit that is different. Here we have to the left 0, to the left 1. Are these equivalent? No, they are not. Are these equivalent? 5 and 5/10 or 5 and 5 thousandths? Nope. would not be read 5 thousandths, 5 tenths, 500 thousandths. There we go, sorry. And 4. We don't have to read anything after the decimal there. Are they equivalent? No, because 5 is greater than 4. So your answer is no. One more. Which decimals are equivalent to this? Choose all that apply. Oh, these are always fun. Notice that word all? That means you're probably going to have more than one. So let's look here. 2,813 and 8. We're going to ignore all those zeros. 2,813 and 8 tenths. Okay, this one is 2018. They've forgotten the 800, so it's not that one. 2,813 and 8 tenths. I can add all the zeros I want behind it. It doesn't change the value. So this one right here is going to be equivalent. What about this one? 2,813 and the 8. Again, 3 zeros here, a lot more there. I can add the zeros. It's not going to change the value. What's wrong with this one? This one's missing something. Couple things. One, I don't even have to look to the right of the decimal. I'll just look here. This is missing a 10. This one has 1 10. This has 0 10, so that can't be it. So I'm going to submit those two answers right there. Okay, that is how you compare equivalent decimals in IXL. Come back for the next video on comparing equivalent fractions.